And this is the group Aggie Drone, and my name is Matthew Rita.
My name is Freddie Sherrill.
I'm Devon Foster.
My name is Berman Thomas.
And just a brief background what the Aggie Drone is basically a portable surveillance device. And so the motivation for, according to the FBI, burglary occurs in the U.S. every 15.4 seconds. And so basically, current surveillance systems in companies and stuff are limited by the range of view and the power requirements. And so what we wanted to do was come up with a universal, user-friendly drone that is able to move on land and move in the air. And so we also want to make it inexpensive and efficient to people. Technical background. Government released white papers about legality of using drones to target threats outside the areas of hostility. And the commercial is basically saying that you can find it in the hobby stores or recreational and professional activities. And then one of the patents we found was that the AR drone developed by the parent has created a patent specifically for its remote control appliance and controls that they want to use. Okay, so the overview, these are links that are going to take you throughout the PowerPoint. And so we have the engineering requirements, marketing requirements, the cost table, the level 0, level 1, level 2 block diagrams, and then also the test documents that we were going to get into later on in the conclusion. So our project goals was to develop a portable surveillance drone capable of manual control. And then also the device will be useful in a variety of applications, basically homes and commercial facilities. And then, like I said earlier, it's going to navigate on land and in the air. And then the controller that we're going to use is through the smartphone.
So the marketing requirements for our drone, we wanted the drone to have a wide range of applications. We wanted to use it in a business aspect, a home aspect, or maybe even military. It should be safe to use, so we don't want any issues with concerns of safety for people. Should be able to be controlled wirelessly, which is we're using a smartphone to control it, Android. It should be user-friendly. We want it to be able to be used not just by people that are technically sound, but people that just want to have some type of surveillance in their life. So maybe someone like my mother could use it who doesn't even know how to work her own iPhone. Also, the device should have low power consumption because we don't want it to draw too much power or too much current because that could affect safety and then you might need a little bit more technical experience. And the device should have a visual system because the purpose of it is to have surveillance, so it does need some type of visual system for surveillance. In talking about our engineering requirements, what this kind of states is, from how we engineer it, we want the battery to operate at least 30 minutes. And the reason for that being is because you want some type of continuous surveillance if you're using it for surveillance. It should detect the light intensity in a particular area. So if you want to, maybe it's nighttime, you've got it at a business, maybe a factory of some sort, you want it to be able to know where it's going. You don't want it to run into objects just because there are no lights. The device should be controlled from a distance of at least 30 feet, which is why we're using the smartphone capabilities with also using it wirelessly. And it should be able to avoid objects or people within a 2-foot radius. And how we're really incorporating that is we're looking to use different types of sensor technology to measure different distances. So going into the functional block diagrams, this is the level 0 block diagram, and what this is it's just the broad overview of the drone itself. It's got the inputs of the drone, which are the battery, the video input, the motor control, and the operator remote control inputs. And what comes out of that is going to be the manual surveillance, which is the actual drone, which is its actual functionality.
Piggybacking off of the level 0, you have the level 1 block diagram where you begin to break the system down as far as the actual hardware and go deeper into the system. So, we'll have a vision system where we'll have a camera that normally takes care of all of that. The master control system, which is our microcontroller, is the Arduino Mega 80K. And we have the multi-terrain system, which is a system that we mounted to the bottom with servos that actually controls the blades. So you'll see that later on in the demonstration. The wireless control system, which is basically everything that goes from the smartphone from over Wi-Fi to the Wi-Fi shield is actually on the board, and then actually communicating to the drone. And then our battery system, which we actually are using these 11.1 volt, 2200 milliamp hour batteries. So the level 1 functional requirement table just takes all of our blocks from that level 1 and starts to talk about the inputs, the control signals, all those things individually. So if we look at the one that we like the best, the master control system, that's basically the microcontroller. Excuse me. That's basically the microcontroller. All the signals that go to it, all the signals that lead from it. As far as the way we control the motors, everything has to go to that microcontroller, and then it actually sends it back out to the motor controller. Level 2 is when you have a block on your level 1 and you actually want to explain a little bit more about it. You want to go into a little more detail about it. So we actually picked our battery system, which is basically the battery system that we use to charge it. So that's pretty much it for that. And the UML diagram, so it sort of describes the flow or the behavior of the system as it actually is taking in these inputs and sending out these outputs. So we start and we acquire user inputs from the controller, which is from a smartphone. So it's just waiting for inputs. And then once it receives those inputs for the terrain mode, then it actually stores that terrain mode, puts the propellers either in a drive or fly mode, and then we actually run the motor controllers based on that mode. Because the drive mode speeds would be different from the actual fly speeds. So we want to differentiate between that. And then it just sends the outputs to the motors.
All right, this right here is our cost.
You want to ask a question?
Yes.
Okay. So you're saying the drive mode speed?
Yeah.
There was 2 speeds you were saying?
Yeah, there was 2 speeds. There's a drive mode speed and the actual propeller speed. When you're actually flying, like right now, it's in a fly mode. So that speed will be at high RPMs. When you actually flip them to the side and drive it on the ground, those will be at a lower speed. You won't want to drive very fast.
It's going to take more for it to fly than it is for it to actually drive. More power.
All right, so right here we have our cost table for all the parts that we have so far, and this is basically just a list. We had a limit like around 500, give or take or whatever. We stayed pretty much within that limit. This is just saying where we ordered the parts from and how much they cost. And so far, we got everything except just for our camera, which we're still waiting to get. Camera and batteries, but other than that, we have everything else that we need.
The camera should be here sometime between October 23rd to November 15th.
And this right here is our work breakdown structure. Basically, we split it up into different, I guess you call it sections of what we wanted to work on first with the whole drone. Like first off, we had like the design, fabrication, building it, then the programming, and how much time we was going to take for each section and like each subcategory under those main ones. So far, I say we're pretty much on schedule on the programming part now. So we're kind of in the home stretch a little bit. That's going to be the part that takes the most, which on here, it actually says that because since we're trying to do 2 different modes on a drive mode and a fly mode, plus using Wi-Fi via Android to a smartphone, then that part's going to take the longest. So right now, that's the stage that we're in now. But overall, it's going pretty smooth. And this first test document is the first one that you have in front of you. The first one is for the sensors for the object avoidance test, which is one of our requirements where it avoids objects within the 2-foot radius of the drone. We're going to be demoing that a little bit later in the presentation. So that's just a test document giving saying our test results and what we got for that. And the next one is this one's for the rotating the motors from fly mode to drive mode. So we're also going to be demoing that at the end of the presentation as well, just to show you how it's supposed to, once you give it a command based off our program, like to tell it to go into drive mode, you see the actual servos like rotate the propellers into that mode, and then the speed or whatever we put in for the input for the speed will go from there. So in conclusion, like to wrap up what we said, existing security surveillance solutions right now is limited by their cost and what all they can do depending on if it's home or for commercial and power requirements. We said that for commercial and home, we want a user-friendly type operating system, like Freddie said, something easy to where it's mild will be able to use it. Also, that just went on to the next thing. But then also the use of the drone will increase security because it can cover a wide range of areas. Plus, you don't have to put somebody in danger having to be in that immediate area, especially if it's like an actual threat to someone's life or anything like that.
So before we start our demonstration, do you have any more questions?
Yeah, I mean, great if you want to for the comments.
No, you go ahead now. We can do the Q&A now.
All right. Back to the beginning. Yeah, I just want to mention the one like before the sun. Yeah, it's kind of.
Yeah, basically what that was is like the links that if you click on a certain link, it takes you to that part of the presentation.
Oh,
It changes the color when you click on
Yeah,
it.
so
I see.
so if you click on like let's say marketing requirements, what's gonna happen is as soon as you click on it, it's going down and take you straight to that link.
Oh,
Yeah, so it changes the color.
It would hit the overview, it takes you back to it that way. See,
Yeah. So we was basically doing our presentation based off of either way.
Okay. Now, oh, now it's like,
Yeah, so
yeah, I saw food. Knee glasses, I'm wearing.
Oh yeah, basically them are all the stuff that we just went through in the PowerPoint. The market requirement, engineering requirement, cost table, test documents, the level 0, level 1 block diagrams, as well as the UML chart.
Now, where's the slide that you were talking on about land and air and stuff?
Yeah, it was in the typo right there.
Oh, okay,
It
that's
could be
all
land
in
and
the
air.
water.
Yeah, it could be land and air.
Yeah, because we actually
don't
was
really-
gonna do land, air, and water because we were gonna mount like close to it, but we sort of after we talked with our advisor, we kind of cut down on some of the things we were gonna do, so we probably got left.
Yeah, so that was like one of the changes we made, and like possibly another change we made that we were gonna have manual and autonomous mode, but as we seen working on time constraints, that we wasn't gonna be able to do autonomous mode, so we just stuck with the manual mode, and our advisor told us to work with that.
Okay. That sounds good. Now, when that's going across land, are they clear?
Right,
Yeah.
right.
Yeah,
Those
so
are
far,
actually
it's
not
just
made
not-
yet.
Yeah.
We're actually gonna get some wheels 3D printed, but it'll actually be a rim that mounts to this casing up here. It'll have spokes that go down, and then it'll be actual rim around these. So that's something that we sort of have to wait as far as the 3D
We
printing.
still in the process of finishing it up, the hardware, but as of right now, we're mostly in the program stage of it.
Okay. Now, that battery will actually be part of the payload, right?
Right.
Yes.
weight of that and with it without the battery? How
I
much
think it's a little under 4 pounds.
total?
Right.
And then how much is that battery weight?
No, I'm saying with the battery, it's a little under 4 pounds.
With the battery, it's only 4 pounds. So is the battery weighing like?
It's very light. It's very light.
Um, So, but you have to take it off, recharge it?
Right, right. So we have a battery charging system that and it's like a sort of special system for these because they're the LiPo. So it's the balancing chargers that we have to keep.
So, now, those two look like eyes, those the camera?
No.
No, those
camera
are the
is not
sensors.
The sensors.
Yeah.
We're waiting on our camera to come in.
Yes.
Okay. So what's the payload gonna be once you put the
Camera is
Camera is really
It's
small,
pretty
but
much
it's only a couple of ounces.
And you can use Wi-Fi to work with the camera and do the surveillance.
It's an IP camera.
Okay, so the video will be recorded someplace,
Yeah.
remotely from there.
Right. We'll actually be able to view the video on here over Wi-Fi because it'll be connected on that network.
Yeah.
That router actually has our network hosting it right
Oh, okay. What about noise? Is it fairly quiet or does it make noise?
We can show you.
now. Well, when we do the test documents, you want to
that's-
just go ahead and go into the test
Yeah.
documents and you'll see
So
it.
that's what we're looking into, the test document, basically, like we said earlier, the test document is gonna show the rollers rotating from air to land, and from land to air. And then the other test documents, the ultrasonic sensors, when like something is close or something far away. So, yeah.
Yeah.
So our first test document will be the rotate from air to land, and then land back to air.
You want to have them look at the phone while you're doing it?
So on the smartphone device, we actually have a Android app that actually communicates over Wi-Fi. So in the background of the app, we can actually set buttons to send commands over Wi-Fi.
Okay.
So then the Wi-Fi shield on the actual board, it receives those commands as serial, and then it converts those. It sends those serial commands to the Arduino, and then it operates off of that.
Right.
So right now, it's a TCP server set back and forth. So when we go, right now we're in flight mode when it's really low. So we're gonna go drive, and that turns the propeller that way. And like I said, it'll have the rim on it as well, so we'll be able to drive from there.
Okay.
And one of the things we did was create a code in our Arduino software,
Uh-huh.
and we was able to make that happen.
Okay.
Fly mode. Fly mode. And then we have two more buttons as of right now that actually control the motor speed. So one actually increments the motor, the values that are being sent to the motor to run them up. And then the other one actually decrements it back down. So this up button actually normal. We don't have it, we don't want to let it lift off.
I mean, it's wanting to take off now, but
Yeah, with that battery's actually stronger than the power supply. So when you hook that battery up to that,
it won't even take that much.
and we have like videos where we actually hold it down. So,
Yeah.
yeah, we just,
See, it's not really that loud for
Okay, yeah.
it to be 4 motors. I know you were asking about that.
And then, did you show them the sensor readings on the?
okay, yeah, I can show you the sensor reader. So, like I said, it's being controlled over TCP. So long as I have that TCP server connected,
Mhm.
I can view any of that serial data that is being sent. So if I want to actually turn it off, I'm turning it on. So we'll simulate like we're flying the wheel right now. And then I have another app that actually shows you the serial readings right now. So that's the loop that's actually telling what's on the sensor. So you'll see what's on the difference. So if I so watch that move up, and the closer I get to it, see the inches actually coming. See it?
So that's basically how it means our engineering requirements. So when it's in flight mode, let's say that it's hovering at like maybe a 2 feet height, and that it's going. Let's say if I'm the drone and I'm hovering and I'm getting close to firming, the ocean climate sensor should be able to read it and realize that it's close to firming and either go left or go right to avoid firming or avoid any object around it.
Okay. Now, yeah, I just imagine that if somebody was driving and they see, well, there's not too much you do about that, right?
Well, I mean, as far as the home application, this is not, it's for, people that have very large homes, that actually want to create a custom surveillance routine. Maybe they may have like a safe or something in their house, or a few places that they really want to monitor while they're away, so you could actually check it out online.
It could get shot down, but you still get your video feed who did it.
Yeah.
Which is the
Through the
ultimate
internet.
purpose.
Yeah.
All right.
Thank you for your time.
Oh, man, this is
That
normal.
concludes our presentation. Thank you.
Yeah.